So let's look at a simple case, right? A class contains 5 girls and 3 boys. So I have 5 girls, 3 boys, and class has decided to form a group of 3 people. How many different groups can be formed such that the first question when I say no condition is that simply saying how many different groups can be formed, that's it. There's no other condition. It says that I have 5 girls and 3 boys in the class and the goal is to make a group of 3. It could be girls, boys. If I had asked question like this, right? There are 8 students in the class and I need to make a group of 3 people. How many different groups can I make? This is simply NCR, right? 8 in the pool, I need to select 3 people to make a 3-member team. 8C3 is the answer. But here, instead of giving 8 students, what did the question say? It actually bifurcated or distributed them into boys and girls. You might see seniors, juniors, or ladies and gentlemen, stuff like that. Doesn't matter on what basis they are. Or maybe sometimes you might see 3 like boys, men and women, right? As children, men and women, something like that. 3 categories, 4 categories. Doesn't matter how many categories they do. All you need to do when the question is simply, how many different groups can be formed with no condition. It's basically, I don't care what's the split. What is the total number of people in the class? I have 8 people, 8 students. I don't care about the gender distribution. 8 students in the class. I need to select 3 out of them. 8C3 is the answer for this. Right? Then the next condition says there are at least 2 boys in the group. Okay, let me first find out what is 8C3. I'll just show it to show the calculations. 5 factorial into 3 factorial. This is 8 into 7 into 6. I know 3 factorial is 6, so this is basically 56. So that means I can select 3-member groups in 56 different ways. Now the question is asking, there's a different question. This is done. We are looking at the next question. How many different groups can be formed such that there are at least 2 boys in the group? Before we get into this or the next one, right? Let me actually explain you something that will help you understand this concept better. So I have to make a 3-member team, right? So in terms of gender, because that's how the split is, girls and boys, what are the different possibilities I can make to satisfy this 3-member team? What I'm meaning is this, in plain English, I can make a 3-member team such that there are 3 girls and obviously it has to be 0 boys. Or I can do 2 girls and 1 boy. Or I can do 1 girl and 2 boys. I can do 0 girls and 3 boys, right? These are the only ways I can do, right? If you ask me how many different groups can be formed out of 5 girls and 3 boys, a group of 3, these are the only possibilities I have. 3 girls and 0 boys, or 2 girls and 1 boy, 1 girl and 2 boys, and 0 girls and 3 boys. I cannot make any other way to make this condition satisfied. So now let's focus on only the first part. 3 girls selected out of what? A pool of 5 girls, right? I have 5 girls in my pool and I need to select 3 girls and is into 0 boys from pool of 3. So it is 3C0. What is 5C3? 5C3 will be 5 factorial by 3 factorial, 2 factorial. This is 5 into 4. So 2 2s is 10. So this is 10. 3C0 is 1. NC0 is always 1. Anything C0 is 1. So 10 into 1 is 10. So 10 different groups can be made from the first condition. Now let's look at this. 2 girls. So how many girls are there in the pool? 5 girls. It is 5C2. This will also be 10. You can calculate. 5C3 is equals to 5C2. That is something we know. Like 10C5 or 10C4 will be equal to 10C6. Why? 4 plus 6 is 10. So that's when these two will be equal. 5C3, 5C2, 3 plus 2 is 5. These both will be equal. That's something you'll realize once you solve maybe more problems. That's basic NCR binomials theorem stuff. But anyways, 5C2 is 10. 1 boy out of 3. From a pool of 3 boys, that is 3C1. Anything C1 is always that value. NC1 is N. So 3C1 is 3. So 10 into 3 is 30 ways. 1 girl from a pool of 5 girls. That's 5C1 into 2 boys from a group of 3 boys. That's 3C2. So it's 5C1 is 5 and 3C2 is 3. So it's 5 into 3 is 15. 0 girls from the pool of 5 girls into 3 boys from the pool of 3. NC0 as I said is 1 and 3C3 NCN is also 1. So that's basically 1. So add them 30 plus 10 40, 55 plus 1 56 ways, which is what we calculated here, right? Over there I just counted as 8 students from a group of 3 is 56 ways, which is the case similar to this. Why? Because that is the only thing I can do, right? If I want to make a group of 3 people from this class of 5 girls and 3 boys, which is 8 students, then I have choices like I select 3 girls and 0 boys, 2 girls and 1 boy, 1 girl and 2 boys, 0 girls and 3 boys. These are the only 4 possibilities. Sometimes depending on situation you might have more possibilities, but why did I explain this? So every problem is basically listing out these cases and then picking the relevant cases. See, what is this? How many different groups can be formed such that there are at least 2 boys in the group? Is the first case correct for the question number B? No, I won't count because I need to have at least 2 boys in the group. I have 0 boys. This is not counted. What about the second? Not counted because there's still 1 by 2 boys. Yes, this is 3 boys. Yes, at least 2 boys is satisfied. So for the B, the answer is just add 15 and 1, that is 16 ways. Right, that is what I need to do. How many different groups can be formed such that there are at least 2 boys in the group? I should have 2 boys or 3 boys. So the only possibilities is the third and fourth, where I have 1 girl and 2 boys or 0 girls and 3 boys, which will come out to 15 plus 1, 16 ways. Let's look at the next option, that is option C, question C. There are more number of girls than boys in the group. Is the first one satisfying the condition? Yes, because 3 girls and 0 boys, girls are more. 2 girls and 1 boy, yes, the girls are more. 1 girl and 2 boys, no, the boys are more in number. 0 girls and 3 boys, also boys are more in number. 30 plus 10 is 40 different ways. The answer for question C is 40 ways. This is 16 ways. You see, that's how you solve it. Being able to split into and, that's why into, R is, that's why I'm adding here, plus plus plus. This is the basic thing that you're doing, right? Earlier we had like 3 roots, 4 roots. Instead of that, here I have NCR. This is what you will get to see in mostly questions, but ultimately splitting them into proper and or and then doing the NCR properly is what you will give you the answer. So only 2 skills that you need to build is figuring out the NCR part properly in these sort of questions, then writing this and or properly in English so that I can get the answer as per the requirement. Any complication that can be added to these questions could be solved by simply doing this. So there's a committee of 4 people that needs to be formed from a pool of 4 girls and 6 boys. In how many different ways can this be done? In the committee is to be included at least 1 girl. I'm going to take a longer approach first to just show you, which we have discussed earlier. So 4 girls and 6 boys, I need to make 4 people. What are the options I have? 4 girls and 0 boys, or 3 girls and 1 boy, or 2 girls and 2 boys, or 1 girl and 3 boys, or 0 girls and 4 boys. Right, this will be from 4 girls. I need to select 4 into 6 is 0. This will be 4C3 into 6C1. This will be 4C2 into 6C2. And this will be 4C1 into 6C3. And this will be 4C0 into 6C4. I know obviously I don't need to know all of this. It's asking how many different ways can this be done if the committee is to be included at least 1 girl. Our committee is to include or have at least 1 girl. So this is accepted, this is accepted, this is accepted, this is accepted. Just this is the problem for me. Right? One way to do is add these 4, right? I'll still do it. I know that it's going to be a bit longer approach, but I'll just show you. 4C3 is 4 into 6 is 24. 4C2 is 6, 62 will be 15, that is 90. So 4C1 is 4 and 63 is 6 into 5 into 4 by 620, so it's 80, right? And I'm just doing this, right, to show, but anyways, I need to add only these 4, right? I don't have to add this. So 25, 105, 195. 195 ways is the answer for this. I know this is obviously longer approach. For things like this, there is a negative approach. What is that? You see in these cases, what is the non-considered, the case that I have to exclude, excluded case, this is this, right? So, if I can actually do total number of committees that can be formed minus excluded case or cases, right, that will give me these 4 values, right, the sum of these 4. What is total? Total is easy to calculate, right? We don't care about the gender. Totally I have 6 people or 6 students in the group. My goal is to make a committee of 4. So that's 10C4 is the total. minus excluded case is 15. That is basically 0 girls and 4 boys. So what is 10c4? 10 factorial by 6 factorial into 4 factorial. That's basically 10 into 9 into 8 into 7. 4 factorial is 4 into 3 into 2. 4 2s are 8 and 3 3s are 9. 3 7s are 21 into 10 is 210. So 210 minus 15 is going to be 195, which is the answer that I got here. Right? This is much easier to do, right? When you see a case like this that include at least one girl or more than 0, etc. So that means there's only one case which has to be excluded. It's good to do in the negative approach.